We don't often think about it, but prior to the 20th century, literacy was unimportant in the workplace. This can easily be seen at Lukens Iron and Steel between the years 1810 and 1925. When Lukens rolled its first boilerplate in 1818, the men who did it communicated prediscursively, verbally and with body language. Until the Civil War, the plant was a simple one. Lukens bought blooms or wrought iron bars from suppliers and rolled them between two heavy rolls to make flat sheets, which they then cut into different shapes. Business prospered, and after the Civil War, Lukens built their first sophisticated technological rolling mill. The rolls were 84 inches in width, and it was powered by steam. Still, even then, life was simple. There was room at the plant for a worker's garden. 1890 was a pivotal year when Lukens moved from early bucolic industry to major intensive industry. On the site of the workers' garden, they built their first open hearth furnace to make their own steel. They also enlarged the mill rolls from 84 inches to 120 inches. This is the point at which the interrelated industrial processes became so complex that they needed to create a system of record-keeping to keep track of it. This is when the workers began writing. By the end of the 19th century, written technical communication had become an embedded part of the industrial process, inseparable from it. Gone were the days of simple prediscursive communication. Today, part of the Lukens plant is still in operation. It's in Coatesville, Pennsylvania, about 40 miles west of Philadelphia. As of 2008, it's operated by ArcelorMittal, the world's largest global steel corporation. Part of the old plant is there, idle and intact, providing us with a rich archaeological resource for the future. In 1810, Lukens bought blooms or bar iron and coal from suppliers, which were then brought by boat and wagon to the ironworks. Finished material was shipped out the same way. This work required very little writing. They did not keep copies of outgoing letters, and incoming ones were folded up and kept in pigeonholes in an old-fashioned desk. If there was any written technical communication, it was specifications from agents and customers describing what type of iron they needed and in what shape. All of the day-to-day financial information was kept in daybooks, journals, and ledgers. The daybook, the smallest of the three, lay open on the counter, and a hand recorded each transaction as it happened. The journal, the middle volume, was updated once per month from the daybook, separated into transactions by subject. Once per year, the journal transactions were transferred into the ledger. It's interesting to note that these financial books were seldom closed. Account balances or deficits were carried on from year to year. There are thousands of these accounting books all across the United States. The first major change in business and technical communication was when letterpress books came into wide use. It was the first copying mechanism that could keep an image of the original. It was the Xerox of the 19th century. Letters were written with a special aniline ink and then, while still damp, placed on a dampened page. If there were multiple letters, blotters were placed between the pages and the book was pressed. Getting a good image was difficult. Letterpress book pages are transparent and tissue thin. The ink often ran or was faint, making the image difficult to read. However, copies of the documents in the letter books were accepted as legal evidence, and consequently many businesses used them. Thousands of these letter books exist across the United States today. Letterpress books are the bane of the researcher, requiring great patience and perseverance to read. They each contain 800 to 1,000 pages, and the ink, if readable, has often faded. Legibility improved greatly with the invention of the typewriter. Lukens bought their first typewriter in 1885. This letter was typed by the Remington salesman. At Lukens Steel, we don't see the handwriting of the workers until after they built the first open hearth furnaces in 1890. When we do finally see the handwriting of the workers, it was mainly for the purposes of data collection. They kept records of many things: incoming and outgoing railroad cars and their cargoes, the chemical content of the ingredients used in the open hearth furnaces, work output by the boilers, and the temperature and flow of steam through the pipes. One of the most important things that they kept was a record of defects on the factory floor. Lukens' specialty was sheet metal for boilers for the locomotive and shipping industries. Since a boiler explosion could cause thousands of deaths, the plates had to pass government and railroad inspection. If the plates had defects, they could not be sold. The initial records of defects were kept by the workers on the factory floor. They were then taken to the office and transcribed into a larger ledger. During the transcription, they were broken down further by defect type. Some of the names of defects in these columns are narrow end, ragged side, sheared wrong, burnt, wrong gauge, blisters, bad surface, pits and snakes, snakes and sand, caught in guard, etc. This data collection enabled them to do research to identify recurring problems and improve the process. It was no longer possible to keep all of the knowledge necessary to the industrial process in a single mind. Multiple minds had to work together. People learned to work together and share their knowledge across distance and time by writing. By the early 20th century, the workers at Lukens Steel were communicating in writing and drawing as well. This was the beginning of technical communication at Lukens Steel. They communicated with handwritten notes folded into rectangles with the name of the recipient on the outside. These notes helped the workers to communicate across an increasingly distributed manufacturing environment. Literacy, quantitative, in writing and in drawing, began to be important to any worker who wanted to get ahead. They needed to be able to record and communicate quickly and well. A very important form of technical communication was drawing. Drawings provided the plans for product specifications, construction of machinery, and any additions made to the plant. Many ideas started as drawings, sketched on scrap paper, were negotiated with others, and the plans grew from them. By the 20th century, most official drawings were blueprints which could be reproduced. Over time, the complexity and the amount of information held in a single drawing increased. Like writing, drawing had become an essential part of the industrial process. The plant was continually growing. In this picture, you can see the 84-inch rolling mill built after the Civil War next to the big mill built during World War I. The big mill had 204-inch rolls and could roll steel 16 feet wide and 25 inches thick. Rectangular ingots had to be poured into different sizes for the different mills. Finding the correct chemical combination, the correct temperature, and the optimal shape was a tricky affair. All of this increased complexity required data collection, the ability to do research to find causes, and increase the amount of written technical communication that flowed throughout the plant. In 1911, another major change in technical communication took place. Carbon paper came into wide use. It was at this point at Lukens Steel that the handwriting of the workers largely disappeared, and in its place were reams of perfectly typed letters, without drawing and without errors. A new worker had joined the force. After 1911, the number of letters and reports containing technical communication grew exponentially, filling thousands of folders. As the amount of technical communication grew, so did its interrelatedness and its complexity. This is when technical communication came of age at Lukens Steel. It begs a question: who were these new workers? In 1895, the office staff included 3 women. Starting in 1911, communications were verbally dictated to a stenographer and then converted into flawless typed text. We don't know who the workers were. Their initials are sometimes at the bottom of a page, but their full names were never mentioned. One of the problems with Lukens Steel in general was that they didn't know how many people worked there. There was no centralized system of management. They had begun with a simple owner-operated system in 1810 and over the years different parts of the plant came under the control of longtime employees. Each manager kept their own records. Also, due to the system of paying men extra according to the tonnage they produced, the men quit frequently when there was little work and then signed on again when the work came in. Overall, they didn't know how many people worked there, and the management was out of control. The simple owner-operated management structure, appropriate to the 19th century, was no longer sufficient for the complexity of the 20th. The two brothers operating the business resigned, and it was taken over by a younger family member who brought the management structure into the 20th century. Lukens lasted as a family-owned business until 1998. Their technological acumen, based in large part on their facility with complex technology, made possible through sophisticated methods of technical communication, took them through periods of financial difficulty and enabled them to last much longer than most steel industries. Their resilience and ability to deal with complex issues led them later to work on the Manhattan Project and to build the lower beams, the three-pronged tines, for the World Trade Center. In conclusion, technological complexity is impossible without writing and drawing. We know that today. We take it for granted, but we seldom think about how it's changed. The need for it began in the 19th century, and the need continually increases. Knowledge is power only if we have the means to communicate our knowledge to others.